One of the more important tools to work with when developing unit tests, especially in the Java language, is a tool such as JUnit5 or, as I'll talk about later in other videos, a tool like TestNG that allows us to automate unit testing. Now, the newest version of JUnit is JUnit5, and there are some differences in how JUnit5 handles things like exceptions and some of the different assertions that are now available in JUnit5. One of the other challenges working with JUnit5 is there are a lot of examples of tests that really don't necessarily follow good practices as far as developing good quality unit tests. So in this video, we're going to work through demonstrating how to do a JUnit5 test development. We're also going to look at a concept called domain analysis, where we can construct meaningful tests based upon the input domain to a given system. And in doing that, we're going to see that some of these methods actually throw exceptions. Those exceptions that get thrown essentially cause us to have to do some things differently in our testing. We're going to see all of this in this video. Now, as we are performing a unit test, there's really three steps that tend to be in just about every unit test we write. The first thing that we have to do is to set up the initial conditions for the test. The things that need to be set need to be there for the test to actually be performed. After we've got these initial conditions set up, then we do something to our code. So we run a method, some sort of an operation gets executed. Based upon that operation executing, then we're able to verify that it is completed properly. So those three steps really tend to be in just about all of our methods. Now, occasionally we will find that for some reason we can maybe skip this initial condition setup because it's going to be set up automatically for us in all cases. And maybe we will find, for example, in the case of exception handling, that this verify operation actually kind of morphs itself up into the performance of the operation. We'll see that as we start implementing some of these methods. A way to remember those three steps that we talked about really is what's called AAA. This is an acronym that, like many things in software engineering, some people refer to as a mechanism for verifying that your unit tests are quality unit tests. The first thing is a range. Essentially, that's that step where we set up our initial conditions. After we have our initial conditions, then we go through our act. That's where we perform our operation and do something. Last but not least, we have our assert, where we're going to check the results. So again, you can see this is very, very similar to what I talked about on the previous slide. Maybe just a little bit easier to remember based on the AAA acronym or the three different words that are there. The class we're going to be testing or demonstrating in this case is something called a word processor. Now, in this particular case, this is not a word processor you'd ever want to use. It's a very, very trivial word processor. Essentially, what it has internally is a list of words that are a list of strings called words. These, basically, if you could picture, would be the words that are typed in your document that the word processor has. We have two constructors here. One of them takes no parameters. One of them takes a list of the initial words. You could think about this as maybe being the constructor that you would use when you were loading the document from a file or something along that lines. We have an Adword, which essentially, if you're typing along on your word processor, every time you would hit the space bar, this would get invoked, adding the next word into the word processor. Last but not least, you have print document, which effectively returns a string representing the text that is now inside of your word process document. Very, very artificial from the big picture of things, but very, very good for demonstrating testing purposes. Now, here on the screen is our source code for this word processing class that we have. We can see that we have this list of words here. We have our constructor, which essentially creates our new linked list. And there's nothing that this does spectacular inside of it. We have our parameters. Now, this word processor, this constructor, will throw an exception if any of the words in the list is not at least one character in length. So we do not want to be able to put empty words into our list of words that's part of our word process document. Okay, that's maybe a little bit artificial, but that is one of the constraints that our Java doc imposes upon this constructor. When we go to add a word, whoops, there's a typo in there. We see that the next word is the word that's going to be added. What it does is it returns the length of our document, the word count, so to speak, every time you add a new word. And an exception will be thrown if the word is not at least 1 character in length. Again, we do not want to be able to add empty words into our document. Our print document here, basically what it does is it will concatenate all these words together to make a nice long string so that we could print it out, send it to our printer, do whatever we wanted to do with it as a printed document. So again, you can see this is a very, very artificial word processor. You don't have fonts, you don't have anything pretty with it. It just really keeps track of the words that are inside of the word processor. Now, based upon the Java doc, what we can do is we can take and split these inputs into different characteristics, different things that we would want to pass in if we were doing what we call input domain analysis. So we're looking at the values, the parameters that are passed in, and breaking them into different classifications that make sense based upon the input. So our constructor, if we note, it doesn't have any parameters, doesn't have any internal data. It's just going to return a new instance. That's going to be a very easy method for us to test. We have a constructor which takes an initial word. Here we see some different characteristics that we're going to have to meet as we are doing our testing in order to make sure that we have good coverage for this constructor with initial words. We have our Adword, basically where we're going to add words to this list. Now, some things, as far as tests-wise, may be covered by our initial words list. There may be some other things that we need to cover based on just this particular method. Print document, again, that's going to be a pretty simple one because all we're looking at is, based upon the words, the return of the words being concatenated together. So we can actually test this one very, very easily because it isn't totally based upon the internal data state of the class. So here we are within the IntelliJ tool, and the steps I'm going to take would be very, very similar in Eclipse, but I'm going to use IntelliJ for this example. What I would like to do is create a test class for word processor. So I go in here and I can create tests. In my case, I want them to be JUnit5. I'm going to call these word processor tests, and I'm going to add a setup. I don't really need a teardown in this particular case. My setup's actually not going to accomplish too terribly much for me. Now, if you look at the automatic generation, it's going to try and automatically generate methods for testing Adword and print document. Generally, I don't use these automated test methods because they are not really in-depth enough for what we're doing. What we want to do is we want to make sure that our tests that we write are independent. We want to make sure that our tests really are only testing one thing at a time. These methods, such as like Adword, are quite complex to test. So we're going to have multiple test methods, or we're going to have something like a data provider that TestNG gives us to do actual testing for them if we're going to refine that way. So I tend not to use these as I'm developing them, but I can actually automatically generate this test class here for my code. So I'm going to have this set up like so. Now, the first thing I want to worry about here is essentially testing the basic constructor. Now, I have these tests pre-written, so I'm kind of looking off screen momentarily here, and I'm going to copy them in. This is my first test, and I need to import the class for the test here, and I also need to declare a variable here that is privately scoped. So WP is going to be my instance of the word processor that I have. I am just, in this case, testing my basic constructor. Now you see I've structured this very, very cleanly. I am making sure that my word processor is null. That's my initial condition. I am instantiating a new instance of that word processor in this line. And then what I'm doing is what I can do right now. I'm asserting that that parameter or that class is no longer null after we've instantiated. So this here is going to test that basic constructor that really has nothing to do with it, or really has no decisions or anything like that, or anything going on inside like that. Let's run it and see what happens. So I'm going to run the test, and if all goes well and good, it passed. Now, if we take a look here, what we have just done is essentially tested this line right here. We need to focus on these other constructors. Characteristics C1, C2, C3, and C4. Now, before I go too much farther, what I want to do is I want to actually put in something that's now that I know that constructor is working, setting up an instance of the word processor. So this is going to guarantee that I have a valid instance of the word processor before I do things. I am not always going to use this instance, but it does alleviate in some regards the need for me to instantiate an instance at the top of every one of my test cases. In this particular set, the way this constructor works, the way this class is set up, I'm going to actually end up in my arrange step doing a little bit more instantiation than I would typically do in this type of a test. Now what I want to do is to start to verify this characteristic ID C1, which essentially is whether or not the initial words is null or not. Now, this is going to be pretty easy to assert if it is null being passed in. In that particular case, I am expecting an exception to be thrown. So I use this assert throws here to verify that an exception is thrown when I actually make my action. Now this is one of those cases where I don't have that AAA, that assert is not there as a separate phase, because I'm doing that right when I'm actually doing my acting. That's not generally the case, but with exceptions that tends to be something where the exception is actually checked for actually in the act phase. So here I'm checking my null parameter. Now I'm not going to write a separate set of initial words where it is not null. I certainly could do that as a test to make sure that if I had a non-null, it would instantiate a constructor or instantiate an instance of the class. I am going to have a lot of tests doing that. Now typically I probably would write that as a separate test just so I could verify that it does return something. I don't really want to have that much duplication in this set of test cases. Now as I go a little bit farther here, what I'm doing is I'm going to start testing for Criterion C2. C2 essentially is what happens based upon the various forms of the parameter that I can pass in, assuming that it is not null, or assuming that I have a list with 0, 1, or more valid strings in it. So here is a scenario where I have no words. You'll notice that my word list is empty, but I am expecting that I get an instance back of word processor from it that is not null. So I'm asserting that WP is not null after I've instantiated. Notice in my arrange step here, I'm undoing that thing that I did up in my initial setup. The reason I'm doing that is because I want to really make sure that I have null and that I don't falsely get this test to pass. Alright, so I have that. Then I have a scenario where I have one word in it, matching that one word. And then in my case, I'm going to do two words because 2 is more than 1. So I'm going to verify that these three things work properly. And again, now I've written some tests here. I'm in my case going to run them just to see where I'm at. And right now, we can see that all of these tests actually are passing. Okay, so Criterion C3, basically what I'm looking for is that the initial words is a list which contains a null string. I have had ones that do not contain null string. I've kind of tested those already, so I'm not going to specifically test those as a separate class. But here I've got a list of words, hello world, that's got this null in the middle. In this case here, again, I'm expecting it to throw an exception, so I am actually asserting that the exception is thrown in my act stage as opposed to having a separate verification or essentially assertion phase where I check the behavior. So I've now done Criterion C3. I want to move on to C4. Now C4, basically what it is it checks that I can actually get an exception if I have a word on this list that is of 0 length. So here I have my initial words that I'm trying to throw in or pass into this constructor that is basically 0 length, and I see a little typo in here and that it is not null that I want to pass in here. For these, this is test words. This is test words. I don't think that has carried over from my other test cases. Good. So I've got both of those being passed in. I'm checking the long value. Here I've got, again, this empty word, which by the definition that we had for this class, as strange as it may seem, should throw an exception as part of the constructor. So I've got this defined. All of these tests, you'll notice, are testing, does my constructor or my sets of constructors work properly? So I can run these again. And we can see that at this case here, all 7 tests have passed. That's a good thing. We like that. Okay, so we have all of these going on. Now what we need to think about is this method. Adword essentially allows us to add a word to a list that already exists. So this again is, I'm typing along, I hit the space bar and have a new word to put into my document in the word processor. So there's a couple different scenarios that I have for this. I could have 0 words on my list, I could have 1 word on my list, I could have more words on my list. Those are the kinds of things that I want to test when I'm adding a word to it. So I'm going to look here at the add word empty list. If I look at my list here, we can see that this is really covered by Criterion C2. I just need to do the Criterion C2 based upon the tests for the add word method, not the constructor. So right now we're going to see some duplication here as I define these. So I'm putting in a couple of tests here. So I've got add word to an empty list. Now, in my case, I am using that default data value that is constructed in that setup method. This is, I think, one of the rare times I've been able to do that with this particular test case scenario. So I don't have anything to do in my arrange stage. My act, I'm adding a new word. The word, or add word method, returns the length, the number of words that are on the list. So I get that. And I'm going to assert that is 1 because I have an empty list. I add 1 word. Now it should be 1. Here I have the scenario where I have as an initial condition 1 word that I've typed into the word processor. I add another word to it. I'm going to assert that my length is 2. I'm going to take, I have 2 words, which represents more than 1. And then I'm going to go through and add a word, now giving me 3. So that is Criterion C2 essentially being set as far as with the initial words. Going beyond that then, I have this criterion here called C5. Now C5 has to do with the word that is being added to the actual words. So C5 says that I want to have a check to see if the word is null, an empty string, 1 character, more than 1 character in length. Each one of those should have some different behaviors. So I am going to set up a valid list here, and I'm going to keep these kind of straightforward and generic. for testing Criterion C5. So C5, I'm going to start here with trying to add a null word. So if I pass null, should throw an exception. So in this case, again, the assert null, I've got the act stage basically indicating that an exception was thrown. If I try to pass in a zero length word, so you notice that it's basically no characters in the string, again, also an exception. If I add a word of length 1, in this case, a, what I'm going to end up with here, I should have a length of 3 when all is said and done because I added hello and world. And then if I add a longer length word, again testing for Criterion C5, hello is being added to hello world. I should have a length of 3 after I add that word in there. So this assert equals basically is checking again the return value of this. It's giving me the visibility into the method that I have based upon the input domain. Last but not least, I need to test this print document. Now, this print document, basically I've got another scenario here. I'm going to print a document that has 0 words, 1 word, or more than 1 word in that word list. So we can see that this method is really just dependent upon the data that is internal to the class in this words variable. So the input domain to test this, I'm going to essentially again use the constructor that takes a set of words in as my setup, and from that I can go about writing my tests. So my test that I have for print document, basically I have no words, which should return an empty string that I have right here. If I have a single word that is a test word, I should get that word back followed by a space based on how this is defined right now. And if I have 2 words, I should see those 2 words concatenated together in a string with a space after it. Those are essentially the things I get from this print document. So I've got all of these tests defined now. Let's go about running them and see what happens. So I can run all of these tests that I have just defined on my code. Ooh, that's not good. I've got a failure. So, exception. Word being added is not long enough. So, let's see. Where did we fail? We failed specifically in this scenario here where I had hello and world as my initial words on the list, and I tried to add a word that has a character length of 1. Now what I need to do is I need to go into Adword, and I can see what is going on that's causing this problem. So if I click on the exception that was generated and go into the code here, we can see that the logic, if next word equals null, we're going to throw an exception. Okay, that's good. Next word dot length. Ow! There it is right there. Ouch. That should be less than 1, not less than or equal to 1. That's why we got that exception thrown. That's why my test case failed. So I make that change in my source code that I have right there. I can go back to my test case that I have defined here, the word processor tests, and I can run this again, and we see that all 17 tests pass. Now, one of the problems you'll see with the way I've structured this is there is a lot of code duplication. There's a lot of code duplication in setting up these initial conditions. That is a problem of the format that I'm using right now. The right answer to this is to use data-driven testing. Data-driven testing, where we use, for example, in TestNG, the concept of a data provider, allows me to define a lot of these initial conditions in a table format, pass those in as a parameter to a test method, and go from there. That's a concept for a later video, but for right now you can see how to set up these unit tests basically with this arrange, act, assert, style. There's very, very few asserts, only checking the things that you can actually check at the end. The preconditions are all set up at the top, and it's very, very easy with this structure for unit tests to be able to detect exactly where the problem is. If you have a scenario where you have multiple asserts in a row, that gets very difficult because as soon as the first assert fails, what happens is the tests will stop running. So if the first assert failed at the top of the test case and you had a bunch of other asserts following onto it, you would not know whether they're working or not. Here I have a very good idea. I knew my code was pretty solid with the exception of that one exception that I had in there. That's what we want with unit testing. We want to be able to have our tests do a very good job of pinpointing exactly where the failure is. So I'm going to bring this tutorial here to a conclusion.